My name is Deanna Hood. I am an electrical and software engineer working in robotics specifically, and I work for a company that makes a 3D bioprinter. So our name is Inventia Life Science, and the bioprinter that we make is similar to a 3D printer that maybe you've heard of or used before, that you put plastic in, but rather than putting plastic in and making plastic structures, we'll put cells in and make cell structures. So these cell structures can be used by medical researchers to print teeny tiny, like micro replica tumors, for example, that are the size of a pinhead, like they're really nanometer type scale. And this can be used in applications for testing different drugs, for example, in cancer research and other things that medical researchers prefer, if they can, to do in 3 dimensions, because that better represents like what we have in our bodies, compared to 2-dimensional like petri dish research historically doesn't necessarily translate to actually what we see in the real world in medicine. My role within that is a specific application of this bioprinting technology, but in the operating theatre. This work will be used one day to print skin cells back onto burns patients. I also have worked on other projects using the same skill set of electrical and software engineering in the past. For example, an application in education that I worked on is that I made a robot that children teach how to write, so that kids who are having learning difficulties with handwriting, maybe they're at the bottom of their class, it would be useful if they could do this like learning by teaching process, that they can teach someone and benefit through that sort of paradigm. But if they're at the bottom of their class, like, who are they going to teach? And so I made this robot that writes badly on purpose, so that children can correct the robot and sort of engage in this like protege effect, and they become friends with the robot, and they find themselves like actually learning themselves and doing practice in like this encouraged way, as opposed to being corrected all of the time, which isn't great for their self-esteem. So this is really similar sort of work that I'm doing technically, but two totally different contexts, and both of them, I think, have a lot of potential to create positive impact on the world, or at least specific individuals in the world, right? Yeah, I think they prepared me as well as they could for projects that like didn't exist when I was studying, like the application of robotics in education that I described, where children teach a robot how to write, that didn't exist before. And 3D printing of a patient's skin cells back into their burn wounds to improve skin regeneration, like this didn't exist before either. So I think that's the challenge. I think the strategy that people take to that is teaching the skill set that will be able to be applied to those different jobs. And so in that sense, the skills that I learned, I happen to use them every day now, because I'm the senior robotics engineer, but I also bring in like my electrical and software and maths backgrounds, and that's come from my training. But at the same time, when I was in university doing the training, it wasn't always clear what that would look like in the real world. And I think that what challenge that causes is that at some point during my degree, I wondered if maybe I should switch to medical engineering. And that's because there were still fake projects, right? Maybe they were doing like a heart rate monitor. It was just a student project for an assignment, but it felt like I had a clearer link to like how I could use that to help people, as opposed to the same actual circuit that we were designing in electrical engineering subjects, just it didn't have that application highlighted as well. So when I saw that there are medical applications of the same skill set of mine that can have like a huge impact, but without actually changing my specific skill set away from what it is that I really get joy from studying and from doing, I was like, oh, actually, I can stick in electrical engineering and have a medical application of my work, or an educational application of my work. We can do anything because almost any project, especially when you bring in software, it's like almost any project that you can point to around the world will have electrical or software or mechanical engineering in it somewhere. So I try to remind people that those opportunities are there and to pick what skill you enjoy learning and enjoy doing each day and stick with that and then find the application later on. I think there's an interesting kind of intersection of soft skills and technical knowledge that is really valued in engineering, which is this like problem solving or critical thinking or inventive step, that sort of work. So I'm part of a team that designs a medical device that didn't exist before. And so inventive process is part of what I do. And the skills that are useful in that is really to think creatively about ways that you can solve a problem. So I'll give you an example from the robot that children teach how to write. There's a robot that is designed for interacting with children. It's called the Now robot. And you can purchase this like off the shelf. And then there are robots that are designed to write. So when we consider the application of a robot that children can teach how to write, it needs to write itself and write badly and that sort of thing. So the robots that are able to write, they're scary, they're expensive, they're ugly. It's not a good fusion for working with children. So one challenge that we had in that project is like, how can we get the best of both worlds here and get a friendly robot capable of writing? And so the creative process that went into that was, does the robot really need to write? Because the one that we wanted to use, a friendly one, not great at like actual dexterity, but we realized in the end, dexterity was not necessary, but just this concept of seeming like it was writing. So it was important that the children could have something to correct and that they attributed that writing to the robot. But that doesn't mean that it has to come from actually the robot holding a pen and touching it to paper. So what I did instead is I took another device, a tablet, and I made writing appear on the tablet at the same time as the robot will point at the tablet. So that small friendly robot is very capable of like pointing in a rough pattern that looks like writing. And then the writing appears on the tablet that is of a quality that can represent like the deformities that we want and has that like dexterity and the precision that we need, but it's actually not coming from the robot. It's coming from this tablet that is synchronized and made to simulate this handwriting of the robot. So creativity in that is hugely important so that you don't just look at what you have in front of you of like, oh, I've got the fancy robot or the affordable robot, but you think of other ideas of how you can leverage more of what's available to you to solve these problems that you have. Problem solving and that sort of like innovation is more likely, in my opinion, to happen when you have more voices in the room, more diversity in the room, all different people looking at the same problem and then looking at it in different ways, just because we're all different people. And you're more likely then to come up with like, oh, but what about this? So that collaboration is useful for that reason, even if you're working with all people that have the same skill set, but often it is necessary. So in that project, I collaborated closely with teachers, for example, because they have insight. They have the insight of how children will interact with it and how to like deform the letters in a particular way that's meaningful. And in my current role on the 3D bioprinter, collaboration is necessary, is crucial, because I don't, as an individual, have the skills to cover all aspects of bioprinting. So I do the electrical and software side of things, which is like the nervous system of the robot. But I work with mechanical engineers who will focus on the movement. We have a lot of like precision that's needed in our printing to create these pinhead sized structures, but they're not doing that in isolation. They're also doing it with biomedical engineers who understand the impact of the forces that are applied to the cells, for example, how too much pressure is going to damage the cells and then they won't be alive at the end of the printing process. Like we need to have all of these skill sets in the one soup for this project to be successful. It's not a matter of choice. It's like, it's a requirement just because we're working at the intersection of these different fields, and one person can't have all of those skill sets. And even if they could, like, I don't think they would be as creative as an individual as in a team. So the day-to-day project that I work on is a skin printing project. So at the moment, we're working on the design of this medical device. So that involves a lot of prototyping and a lot of thinking about what we're going to need to satisfy the user requirements and like the user needs. So we have to work very closely with surgeons at the moment to make sure that the product that we are designing in a technical sense will actually be useful in an operating theatre. They're not just to optimize the system, it's to make the system safe. So most of what our prototyping is involved around at the moment is not so much how to technically make the printing possible in an operating theatre, because we have the printing technology, but how to make this system safe for interacting with patients is a lot of our design thinking. I would advise people to talk to as many engineers as possible to appreciate that there is so much variety in the industry, but to not let that be overwhelming. Like, there's so many things you can do with engineering. And I think then it would be tempting to be like, I can't see what my career would look like, so I'm just going to pick something where I know what I would be doing. And I think in engineering, just try to think of it as like, what I would be doing is electrical or software or any type of engineering. That's what you would be doing, but that's not why you would be doing it. Like, why you would be doing it, you get to choose. If what you enjoy is mechanical engineering, just like trust in that what you're going to be doing is mechanical engineering, but why is totally up to you.